In this first problem, you are asked to answer several questions about several different types of functions, and these questions include to determine the domain, Y-intercepts, X intercepts, which are also the real zeros of the functions, and also to answer if the function is an even function, an odd function, or neither. So let's look at the first function, fx equals to x to the third power minus x. This function is a polynomial function, and as you can see, there is no restriction in terms of what x can be or cannot be. Therefore, x can be any real number. Therefore, the domain of the function is simply a real number. The y-intercept of a function is determined by plugging in x equals to 0. Therefore, when x equals to 0, fx equals to 0 to the third power minus 0, which is again 0. Therefore, the y-intercept for this function is 0, 0, which is the origin. The x-intercept of the function is determined by setting the function value to be 0. Therefore, x to the third power minus x equals to 0, and then solve for x. So this equation shouldn't be that difficult to solve. We can first pull out x, and then that's our common factor, and then we're left with x to the second power minus 1 equals to 0. This can be further factored to be x minus 1 and then x plus 1 equals to 0. Therefore, you have three factors for this equation. Therefore, the solutions will be x equals to 0, x equals to 1, and x equals to negative 1, respectively. And these are the real zeros for the function, and correspondingly, the x-intercepts are 0, 0, 1, 0, and then negative 1, 0. And to determine if this function is even, odd, or neither, we follow the rule that if f negative x equals to fx, then this is an even function. On the other hand, if f negative x equals to negative fx, then this is an odd function. And if f negative x does not equal to either one of these, then the function is neither. So in this case, f negative x equals to, just replace all the x in the function by negative x. So in this case, negative x to the third power minus negative x, which equals to negative x to the third power plus x. And if we compare this to the original function, we can realize that this equals to negative of the original function. Therefore, the answer to this problem is this function is an odd function. For the second function, square root of 4 minus x squared over x squared. First of all, the domain requirements. We know that whatever is underneath the square root must be non-negative. So in this case, the first requirement is that 4 minus x squared has to be either bigger than or equal to 0. Therefore, x squared must be either smaller than or equal to 4. And then we take the square root on both sides. Don't forget, when you take the square root on both sides, what you get is not simply x is smaller or equal to 2. That's not correct. It should be absolute value of x is smaller or equals to 2, which means that x could be anything between negative 2 to positive 2. So from the first requirement, negative 2 is smaller than x, smaller than positive 2. But there's a second requirement that the denominator cannot be 0. So in this case, x squared cannot be 0, which tells us that x cannot be 0. So combining these two, we can come to the conclusion that x can be anything between negative 2 and positive 2 except for 0. Therefore, negative 2 smaller than x, smaller than 0, and also 0 is smaller than x, smaller or equal to positive 2. And that is the domain for this function. Y-intercept, again, plugging in x in order to solve for y-intercept. However, in this case, because x cannot be 0, otherwise the denominator is 0 and the function is undefined, and also 0 is excluded from the domain. For this reason, we cannot evaluate the y-intercept for this function. For the x-intercepts, we set the function value to be 0 and solve for x value. So in this case, square root of 4 minus x squared over x squared equals to 0. And because the denominator cannot be 0, so the numerator must be 0, which means that 4 minus x squared must be 0. Therefore, x squared equals to 4. Then again, taking the square root of both sides, we will end up with two answers, x equals to either positive or negative 2, corresponding to the two x-intercepts of negative 2, 0, and also positive 2, 0. And x equals to positive or negative 2, these are the real zeros of the function as well. And then to determine if the function is even, odd, or neither, f negative x, in this case, equals to square root of 4 minus negative x squared divided by negative x squared, which equals to, we know that negative x squared is the same as x squared, therefore square root of 4 minus x squared, again divided by x squared, which simply equals to the original function. For that reason, this function is an even function. The next function is a piecewise function. It equals to x squared when x is smaller than 0 and x equals to 5 when x is bigger than or equal to 2. So as you can see, the function is only defined for intervals of x is smaller than 0 or bigger or equals to 2. And that is the domain of this function. So you can simply copy that, or you can write it this way. The u means the same thing. Okay, so that's the domain. The y-intercepts again is calculated by setting x to be 0. However, x equals to 0 is excluded from the domain. Once again, the function is not defined for x equals to 0. Therefore, once again, the y-intercept for this function does not exist. To determine the x-intercepts, or the real zeros, we need to set the function to be 0. So we do that by setting each of the equations to be 0. If we set the first equation, x squared, to be 0 and try to solve for it, the solution will be x equals to 0. However, x equals to 0 does not belong to this interval for which this equation is applied. Therefore, this is not applicable. Then we look at the second equation and solve for this equation, x minus 5 equals to 0. And apparently, x equals to 5, which does fall into this interval, which is a valid solution, and that is a real zero to the function, and that corresponds to an x-intercept of 5, 0. Lastly, to determine if this function is even, odd, or neither, if you don't know how to do it algebraically, you can easily determine that by sketching the function, because the first equation is a squaring equation, and we know that the graph looks like a cup, and this applies to anything that is below 0. Therefore, this graph only has half of the set, and also the origin, this point, is excluded from the graph. The right-hand side is a linear function. Therefore, x minus 5 can be sketched as this. And this point, we just determined this point is the x-intercept, and that's 5, 0. So just by sketching it, or even if you only know that the left side is a curve and the right side is a straight line, you can tell that this function is not symmetric about either the y-axis or the origin. Therefore, the answer to this question is neither. Don't forget, even functions are symmetric about the y-axis, and odd functions are symmetric about the origin. That's how you can tell graphically if a function is even or odd or neither. For the last rational function, because the denominator cannot be 0, therefore 2x plus 3 cannot be 0, 2x cannot be negative 3, and then x cannot be negative 3/2. And that is the domain of this function. X can be any other real number except for negative 3/2. And to determine the y-intercept, again, plug in when x equals to 0. So f0 equals to 0 minus 9 divided by 2 times 0 plus 3, which equals to negative 9 divided by 3, and that is negative 3. Therefore, the y-intercept is 0, negative 3. To determine the x-intercepts, you need to set the function to be 0 and solve for x. So x minus 9 divided by 2x plus 3 equals to 0. And for that to happen, only the numerator can be 0. Therefore, x minus 9 equals to 0. Therefore, x equals to 9. And that is the x-intercept. To determine if the function is even, odd, or neither algebraically, f negative x in this case equals to negative x minus 9 divided by negative 2x plus 3. And if you compare this to the original function, this does not equal to fx. This does not equals to negative fx. Therefore, the answer is neither. For the second problem, you are asked to use the graph of fx equals to square root of x to graph a new function gx equals to 1 minus square root of x plus 4. If you compare gx to the original function, you should realize that there are several steps of transformation involved, and you should be clear of what these steps are. The first step, we can write a new function that is, let's call it hx equals to square root of x plus 4, and if you compare that to the original function fx, that is f x plus 4, and we know that because of this plus 4 inside the parenthesis, that indicates a horizontal shift to the left by 4 units. Therefore, hx should look like this, with this being 4 units, shifts to the left. Right now, we don't have to be accurate, we're just doing sketches. The next step, on top of hx, we can write a new function, let's call it sx equals to negative square root of x plus 4. And if you compare that to hx, that is negative hx, and we know that this negative sign happening before the function, that indicates a reflection about the x-axis. Therefore, sx should look like this, which is a mirror image of this blue curve. And lastly, we have our gx, which equals to 1 minus square root of x plus 4. And if we compare this to the sx function, this equals to 1 plus sx. And this 1 indicates a vertical shift up by 1 unit. Therefore, based on the green curve, we need to move that up by 1 unit. So that's the sketch. Now, to be accurate, we need to determine the x and y-intercepts of the function. To determine that, for the y-intercept, all we need to do is to plug in x equals to 0. Therefore, g0 equals to 1 minus square root of 0 plus 4, which is 1 minus square root of 4, which is 1 minus 2, which equals to negative 1, which tells us that the y-intercept is 0, negative 1. For the x-intercept, we set the function to be 0, 1 minus square root of x plus 4 equals to 0. Solve for x. Square root of x plus 4 equals to 1. X plus 4 equals to 1. X equals to negative 3. And that indicates an x-intercept of negative 3. Therefore, with that knowledge and with the sketch of this red curve, we know that the starting point right here is negative 4, positive 1. The x-intercept is negative 3, 0. The y-intercept is 0, negative 1. With that information, we can now sketch the function to be, and this is our gx function.